But anyway, let's move to our little panel discussion. As Peter, you are tall, you can use the table. But others, we have a chair for you. So it will be Ismo and Ivette, Marilu, Chris, and Tuomo. And watch out, I put the stairs in the podium, but they have wheels, so you may fall off. I mean, alternatively, we take them down, whichever. Let's take them down, yeah. Yeah, that's safer. Yeah, I think we don't want to have a gravity too much. And right, so as you can see, the chairs is here, of course, not this mobile. Yeah. And so, and of course, I think I'm very happy also to introduce Professor Marilu Chiofalo from the University of Pisa, who has been coming to many of our events, and she very boldly came from actually Copenhagen this morning. She was there doing things and presentations, and but she was able to fit in a day and night in Helsinki, which we are very grateful for. But anyway, so I don't know if anybody who want to start, who has something in mind. It could be commentaries both, of course, to Peter, to Tuomo, or the relation, or any other comments. Yeah. There's Chris. Okay, you start.
Yes, I'm still a bit puzzled as to how your mass resonator. Well, there's two questions really. One is, what is confining the wave there? You know, you say it's a resonator, but you wouldn't normally have some boundary for this thing to resonate in. So how do we understand that?
You mean the particle described with the Compton wavelength?
Yes. Yes.
Yeah, it simply came from the fact that Compton wavelength can be expressed as H0 divided by mass.
Yeah. Okay. But I was just wondering, you know, normally when we think of, you know, the waves resonating in this room, it's because there's a wall there and a wall there. So is there something similar which is confining these?
Of course, I can't describe what's the internal structure of the resonator, but it must be spherically symmetric, I would say. No. Okay. That and for simplicity, I look what happens in the direction of the motion.
Yeah.
And we could find that the Doppler effect. In fact, we could make exactly the same analysis by checking the radiation pressure at the different ends of the resonator. We could get exactly the same result.
Uh-huh. Yeah, and the other.
So the Doppler effect is more like kinematic approach to the same, but we could also follow momentum or energy.
Yeah. And then the other question is I think I've asked it already actually, is how does this mass wave resonator, how is it guided by the extended momentum wave? What, you know, because we don't have any, you know, equation for this, then it's hard to understand how, because you know, even when you talk about, well, I'm going to use the classical wave theory, but of course there aren't any trajectories with that unless you go to the geometrical optics approximation, or if you want to do physical optics, then you know, you would then have to have some way of saying how this thing, how your mass wave resonator actually moves within this wave structure. And I think drawing the straight line that you drew, you know, I don't know where that comes from. It seems a little bit ad hoc, that you should just draw that. So you need a bit more. That's why I think you should just take your geometry and put the Schrödinger equation on there, and then.
That's a very difficult question indeed, because what I basically think is that it follows more or less classical way of trajectories if it's not affected by other component of momentum. My intuitive idea in the double slit is that in the interface case we get some we finally get perpendicular components to the momentum. So the particle trajectory in my thinking is determined how it passes the slit. If it passes from left side, it then tends to turn to the left. And here, according to the very classical idea of starting from a kind of spherical spreading.
Okay. Yeah.
So I don't have any better answer. So
okay. Well, I appreciate that this part of your theory isn't fully worked out. But then the next question, of course, is what happens if you have two?
I would be very happy to hear that also.
Yeah. If you have two particles now, how and then you have all the non-local effects coming in. This is again, which is it would be great if you've just put the Schrödinger equation on your geometry. Then you could have also. Configuration space, but this might just move a little bit far from your physical idea. So anyway, I don't want to dominate. So
in fact, it should be extremely interesting to find out that how far can the momentum wave be considered is described by the Schrödinger equation. That's because I'm looking for physical explanations, so that's why I'm very interested in finding the physical explanation for any phenomena or any mathematical concept we are using.
Okay. Sorry. So maybe I'm going to sort of jump a level and just talk about, let's say that we've been discussing like different approaches. Some of them have some things that look similar and overlap and so on. But I'm wondering also about the philosophical talk yesterday that you were saying about how do you choose a good theory and so on. So how do we choose what is the right approach, right? I think we're back a little bit to square one, where we have like a collapse or reduction version, and there's like a Vomian mechanics, and now it's a completely different approach. The big to the small and stuff like this, but I think we have a big difference now than 100 years ago, which are the experiments. So, but it is good to discuss, like as a community, how do we approach that? Because I think it would be nice maybe to not have it as a competition and see who's right. It's more how can we combine our knowledge, our approaches, how can we together come to something and use the technologies? Because I think one of the things why I fell in love with Bohm was all his discussions about how to communicate, how to collaborate, how to see us like one humanity trying to solve these problems. And sometimes when you're like in science and you're applying for grants, and so it's completely the opposite thing. It's like a war, and this is not nice, no? So there are some resources, and there's now real experiments, like really ways to test things. And maybe to think a bit about that. And just very quickly, I wanted to also comment on what you talked about, the intuition and that feeling things. I would like to talk more about that topic as well, because I think this is something that in this era we've forgotten, because everything has become so rational and some logic. But I think, for example, I was very lucky as a woman, because maybe when we were little girls, we were allowed to feel a lot more than men. So when I started to do physics, I could feel the physics in my body and in my feelings. And instead of suppressing it, I let it grow. And this is how I work, actually. I work from a feeling, and then I try to, at the end, put the logic into it. But it would be nice to discuss that also.
Ismo was asking.
Okay, thank you. I would like also come back to this Bohmian trajectory ideas and how you presented it through these fluxes. It's interesting, and I can see certain connections between the way we are today dealing with certain experiments, and Ivette also mentioned, where we can make these weak measurements and positive operator valued measurements and track the system's state by non-invasive measurements, and then we can recover something like these fluxes, or basis how we can extract information of the predictability of the quantum coherence in certain places. So are you aware of any research done along these lines that these kind of descriptions of the same phenomena, for example, this double Stern-Gerlach experiment is very interesting in this respect. Even more interesting would be the Einstein-Podolsky-Rosen type experiment where we can test the Bell inequalities.
So, yeah, thank you. So at UCL for the moment, there is an experiment that's kind of there. We're missing people to run it. There's one person who kind of holds it all together. Rob gave an explanation, a little bit of that experiment. And it was set up originally to study the weak measurement, okay? Because Basil felt that that was a very important. And both experiments that Rob showed yesterday, the Stern-Gerlach and the argon, trapped and kind of double slit or multi-slit, both of them had this kind of weak measurement. Now we moved over, because personally I have doubts on the weak measurement per se, but the idea of mainly more pre-selection, post-selection idea is being developed. I took away the slide because of time for the moment, but the idea is to use what's called something similar to a stirrup thing, so where you kind of encode the effect of a laser with your beam, with your particles, in such a way that that encoding depends on the Doppler shift, which would be due to the Bohm velocity. And now the clever trick is, hopefully, that your encoding or your weak encoding is such that you haven't collapsed the wave function there. But what you can show is that then when you do your strong measurement, you can kind of decode, or you can kind of see the effect. You're not measuring the velocity, but you're measuring the effect of that velocity, because you just change population in your sample. And so that would be, for us, the main objective, because it would allow us to then measure the velocities clearly. Well, there's always going to be debate, and that's, as I said, between kind of standard quantum mechanics and the explanations of things. I think the whole idea here is to just push to say, well, look, there's a question here. There is this happening, and please don't go down the route of fiddling and finding an extra term, or doing an expansion which shows that. No, kind of go back to the basic, to the intuition of what is happening. Yeah.
Completely agree.
Yeah. And
the experiment and evidence coming from the
yeah, follow the experiment, because coming back a little bit to the discussion there, you see, for me the whole idea is not the Bohmian mechanics compared to the standard or whatever, the many world and all of that. It is, we've got things there, let's look at them, and let's also accept, I feel very strongly that in a couple of 100 years' time or 400 years' time, we will all look very stupid. It's a reality of life, yeah, but it's true. We look back 400 or 500 years and we say, how could they believe in this thing? Yeah. And I think we are still at a stage in our development of humanity, if you want to call that, where we don't yet have all the tools to describe what we're seeing, to kind of work with what we're seeing. So what we need to do is have that open mind where we can kind of look and say, well, look, there's this there. What can we say? What can we do? And then, that's where the dialogue has to go in. Because if we go down the route indeed of, trying to apply for money for specific things, we're going to go down that route and we'll stay very comfortably there, but we're not going to move very forward. At least.
Thank you. So I'd like to add one more item in the discussion, but also, first of all, follow on what Ivette said. As women, we are entangled, so we also had the red glasses, both of us, without deciding earlier, before, without agreeing before. So, following Ivette's comment, one specific type and class of experiments that now with these technologies 2.0 are available is about entanglement. So one question is how, for example, in the two approaches that we saw today, entanglement is seen, and also the generation of entanglement. Specifically for Peter, I had a question about, but also for you, I mean, how entanglement comes out from the theory. But for Peter, also how the uncertainty principle comes about in the theory. And since this is something we would like to use fruitfully, for example, in quantum metrology, etc., then it is useful for all the kind of general relativity tests, etc., that we wish to make. I think that this is one, can be a relevant question. And then the other item that I would like to add into the discussion is, since also, again, I'm taking from Ivette, because she was saying, how do we classify these approaches, etc. So one first classification will say whether there is an ontology or there is not an ontology. And I think it's more or less clear what's going on, but maybe useful the discussion. But then question is, shall we have to put in also the other great mystery that is completely unsolved, that is consciousness, like Roger does, for example? Who's going to start?
I'd like to start, yeah.
So whether we should
I can say yes.
whether should be considered, should be part of the...
Okay, well, just a quick one on the Heisenberg uncertainty principle, because it doesn't apply to individual particles, so it doesn't rule out the trajectories. So the Heisenberg uncertainty principle is just a principle about the statistics of the results of measurements, positions or momenta. And what you see in the Bohm theory is that you always reproduce the results of quantum mechanics. So if you look at an experiment in which you measure position repeatedly and you build up the statistics, and then with the same wave function you measure momentum and you build up the statistics, you get delta x delta p greater than h bar over 2. So it's about these statistics.
On the order of the operations that you make.
Sorry?
It depends on the order of the operations that you make.
Yeah, so anything in quantum mechanics, well, what you do is you set up the experiment, you measure x, start again, set up the experiment, measure p. Okay, so it's always a different... Or you could do it, and it's just the same. So there's no issue certainly in our approach, the Bory-Bohm approach, for that. And entanglement, well, it's very straightforward. And I think one thing...
So there will be an entanglement of trajectories also.
Yes, so as I said yesterday, but you weren't here, but the Bohm theory would then has to work in configuration space, okay? And then everything is local in configuration space. And you see, a very, very straightforward explanation of how these events which occur in our sort of 3D space at great distances are correlated because of what's happening in the configuration space. So it's very straightforward in the Bohm theory. And I also agree that experiments are, critical in this. And I think, if there's ever an experiment which shows quantum mechanics is wrong, that would be the most amazing thing. But it would also show the Bohm theory to be wrong, because Bohm theory is just quantum mechanics. So,
About the entanglement as I already stated, in the dynamic framework, we can see that necessarily gravitation, for example, means immediate distant interaction. It's not interaction in a sense that there would be something that traveled from one location to another location, but the information is in the form of the potential energy. And yesterday we were looking the system of nested energy frames, which follows the conservation of the energy balance between motion and gravitation. And I could, at the conceptual level, I could see that it's a question of exactly the same phenomena that we always need, if we are breaking something within in a frame where motion and potential energy are in balance, and taking something out, it must be balanced. So that basically.
But it would not be only an action at a distance.
Yeah,
right? But a correlation at the distance. So what happens if you make a measurement of one piece? You should be sure of what you get.
I'm not able to come into details, because what we need to do to go very carefully understand what happens in the experiment, also in what is the measurement, because that's also a conversion of energy. Measurement is a conversion of energy, and when we take all that into account, then perhaps we will find. Hopefully some do that. I would be interested to hear the result. Very, very interested. Yeah. Also, you mentioned about the collapse of wave function. If you mentioned,
I have a different approach to
well,
things.
because if you accept, or if we assume that the wave function really describes the momentum wave, if we stop the motion of the particle, then the momentum disappears automatically. So there's no magic in that.
I find your ideas very interesting, but I find them very difficult to connect to the physics that I am used to, right? So that is an important thing, because when one comes up with a new idea and stuff that we definitely need new ideas. So I'm open for that. But then there has to be like a big effort to connect to the things that one knows, and that is the difficulty. That so when you say something like this,
very, very well.
yes, because when you say something like this to me, I don't really understand what you mean. You know, so there has to be some kind of also like about entanglement, because the way we understand, let's say, entanglement could be through Bell's inequalities or something like this, because it's not just one measurement that is important with the correlations, is the three measurements. So that is where, talking also about how do we approach this, let's say, new era. I like to mention that, because I say something about consciousness. And so I think one thing would be we need to try to connect on the things that we each know, so that we can, okay, yes, now I see the value. Because if we don't connect like this, it's very difficult to sort of move forward. So maybe you need to get groups to work together on one thing that everybody can see, yes, this is where the approach is connected, you know? So that could be, and we could maybe do it through students, okay, look, I don't understand very well what you say, but maybe we can find a student that helps connect this, and maybe it's in a little thing, it doesn't have a big approach. But I wanted to comment on something that you said about how silly we will look in the future. And this is always the case, right? We always look at things in the past and say, oh my God, they believed that turtles were under the earth, and oh my God, the spontaneous generation and all of these things. But I think having this in mind gives a lightness to what we're doing. Let's not take ourselves so seriously. Let's have fun. Let's say, like, okay, we're doing our job in this moment in time, but let's do it with joy, a little bit like children, because then it's not, when they look back at us in the past, they will say, well, at least they were just having fun. And it's like, yeah, I think this lightness is very important. Talking about, again, going about the gut feeling and stuff like this, in my opinion, being light, having fun, this is super serious. And no, having a little bit of fun relaxes the mind and the creativity comes in.
I want to just, I said people would look stupid. On the other hand, I look at some people, somebody like Einstein, or things that were done roughly at the same time when people were killing themselves in the fields.
Most of us will look silly.
And then you see these other people who have these brilliant ideas. I mean, how they could emerge with these ideas in the environment they lived, and we are so comfortable in our own environment, is still phenomenal.
Yes.
It's a balancing act.
And yes. So, and I wanted to pick up on what Marilu said about consciousness, and I would like it to stop being a taboo. Yes, this is what I want. I mean, come on, we're all conscious, right? So I find it really, so I was told in some serious environment to please erase the word out of my document, okay? And I did, I choose my battles. Yeah, but I'm thinking people here are talking about the horrible disasters in the world, wars, and all of that is okay, but it's not okay to say, look, we're all conscious, can we take this scientifically serious? So I don't have at all an approach, and anyway, how to connect my work to consciousness. I have no idea how to do it. But I really, in my gut feeling, I want it to stop being a taboo.
I think one of the problems is that the way our modern science has been constructed is specifically to exclude consciousness right from the beginning. So the idea that you would ever find it with our modern science is hopeless, I think, in a way, because it's set up not to be there.
With approaches like more like holistic approaches, we do, but to start with, because for me to jump from my approach to an approach like this is a big thing, but at least to say that maybe we're ready for that, or we're needing that, or or that we are at least able to discuss it without being called a crackpot because you mentioned the word. Come on. Yeah.
I have a question there for experimentalists, because how do we get to the point? I mean, in theory, we're a bit more relaxed, but for experimentalists, you're very constrained by applications for grant and and doing research and justifying why you need to kind of look for these things. And is there any kind of interest, you think, to get back to a stage where you're much more free to look for something that is not really being questioned for the moment?
In AI, AI brings it completely. The people working on AI are super interested to find out if they will ever be able to. It's a big debate there. I think not, but that's a big debate right now, and a lot of people are discussing. That's why there's been a little bit of a resurgence in it, because many people working with AI think that it's a matter of complexity and time that AI will become conscious.
Yeah, no, I was going to something. No, that's part of the thing. No, I'm thinking about, kind of messing about with stuff. Because you were going back to this kind of gut feeling, the intuition and things like that. And, because sometimes as a theorist, I look at experiments and I say, well, how much are they being guided by the theory? That they're looking for something that the theory has pushed them into a kind of, because like the theory has been asking a question to you, and maybe there should be more freedom. Yeah.
If I can say one thing about it. Because one other very important thing that is happening with this quantum technology availability is that a new relationship between theory and experiment is coming about. And I think that we should change mentality and mind in that. Because before this, what was the relationship? So it was the Galilean-like relationship. So I observe, then I make a guess, then I formalize it, and then I make a new experiment to prove or disprove. But now there is a situation in which theories, and so there it's clear who does theory, who does the experiment. Some big names did both, but still within this kind of cyclic. But now theorists, they design experiments. Here we have one, Ivette is one. Design experiments that are not just meant to prove or disprove, but they can be also meant to make simulations of reality. So, ad hoc quantum computers, to say, that make the calculations for you, the calculations that you have in mind with the theory. So everything changes. So it's a completely different scenario. And also in this respect, I think that we should abandon this idea of logos, so intelligence of the world, of reality, that is just our brain with the logos, the logic, etc., that looks at reality. Ancient Greeks had a second word for intelligence that was metis. That is a much more practical intelligence that is completely embedded into reality. And so this comes back to the point about ontology, consciousness or not, etc. And so I really think that we should reconsider the way in which we do research.
Okay, thank you. Interesting discussions. I try to comment at the same time, Ivette and Marilu, and also this question about consciousness, reality, and theory and experiments. So there has been a lot of discussion about the relation of quantum mechanics to consciousness, and it's an old topic going back to 30s. And I feel that it's important connection, but I feel also that we need to turn the tables. We have been asking questions that how consciousness can be explained by quantum theory. But this is somehow circular. Our consciousness has created quantum theory. It's the theory, it's the understanding we have the reality, which is obtained through experimentation, experience, evidence, all such things. The reality we are living in is material reality. It's not some Platonic hidden reality. Theory is telling us that reality is something which appears only in very limited way in real experience. Experience is the only reality we have. And to describe that reality, we have created quantum mechanics. And it attempts to capture something like phenomena which are not predictable, which are probabilistic, which are entangled, which are out of control, which are somehow undecided, like Schrödinger cats. Schrödinger cats don't exist in our reality. But when we think different kind of things, when they are objects of thinking, we can think these kind of relations. And it provides us new means to interact with the reality, invent new ways to interaction, to be a kind of participant in the events of the reality, kind of agential attitude to interact with reality. And as probably Marilu mentioned, it's a very different way to think about relationship of humans to nature, that nature is not something outside we are using or we are affecting it, but we are part of the nature, living with the nature, and essential part is acting with the nature and the material nature of the nature together, and that's reality. And quantum mechanics is important to provide a new viewpoint on that reality. So,
yes, I let Ismo have the final word. I think we have already a little bit into the background. And so we now, because we have a tight schedule, because we have to get out of here at 4, so we'll have now this lunch break. Let's try to be back by 1:30 for the next talk, and then I have some here for like the speakers and some of the like the project members and some guests, and others I recommend you. Kluvi is full of places where you can get the quick snack. Somebody really wants to make it simple. There's an R kiosk. If you go out and turn right on your right, you get a little snack there. It's a little tight to schedule, but unfortunately the restaurant here is not open, so we'll have our little lunch over here. I will be a magician and show how we get it, and then for the others, see you. And again, I say that 4 o'clock when we end it here, everybody is welcome to join us to the philosophy department just down the road in Yliopistonkatu, or actually Fabianinkatu, and we have also some refreshments there. So, but then we must do that together because it's locked. We must go in a group. So we will wait everybody at 4 o'clock, maybe outside the building if it's not raining, and so you are all welcome. But now, let's thank the excellent panel for the excellent discussion.